Hello, calculus fans. Okay, we've spent some time working on absolute extrema. Now we're going to return our attention to local extrema. Now the derivative of a function can actually tell us a lot of information about local extrema. And we're going to use a couple of theorems to help us find local extrema. The first one is the first derivative test. Later on we're going to have a second derivative test. Now let's suppose that c is a critical number of the function f of x. Let me remind you what a critical number is. It's a number that's in the domain of the function where the derivative either doesn't exist or is equal to 0. And so we can use the first derivative now to tell us whether these critical numbers are local extrema. So if the derivative changes sign from positive to negative at x equals c, then we're going to have a local maximum at c. So the function is increasing and then it's decreasing. If f prime of x changes sign from negative to positive, then there'll be a local minimum. So on the first one, you should just imagine it's going up, then it's going down. That's how you know you have a local maximum. The second one, the function is going down, then it's going up. That's how you get a local minimum. Now it can also happen that the derivative does not change sign at c. So it could happen that the derivative is positive on both sides or it's negative on both sides. And if that happens, then f of x will have no local extremum at that point. You know, the picture that you should have in mind for this third case is things like y equals x cubed. You have a critical number, but it's increasing on one side and increasing on the other, so you know that there's not going to be a local extremum at that point. I would suggest looking at the pictures in the book that illustrate the first derivative test. They really encapsulate everything about the test. Okay, that's all for now.